Hello, welcome to math video number 18. Today we're going to be talking about SOL 4.14. It says the student will collect, organize, display, and interpret data from a variety of graphs. Today we're going to be focusing on bar graphs and line graphs. So bar graphs are used to compare counts of different categories. I'll show you a couple examples of those. Line graphs are used to show numerical change over time. So it depends on what type of data you have that determines what type of graph you need to make. So first, in order to make a graph, you need to collect your data. Now, there are lots of ways to collect data. You can make observations, take measurements, do a survey, do experiments, walk around your neighborhood and take a poll or do a questionnaire for your family. Lots of ways. So for my first graph, I took a poll, and I actually took this during our Reading Cost Connect last week. So if you were attending live last Wednesday, your data is shown on our graph. So my first question to the Kluffman kids was, what is your favorite summer activity? So here is my data represented in a table. It's a really great way to keep your data organized. So I listed the favorite summer activities that I gave them as choices along the one side, and then I wrote down the number of students who chose this activity. Okay, and then I created a bar graph. Ooh, okay. So you can clearly see that there was a favorite summer activity by looking at this bar graph. So for a bar graph, what you need is a graph title at the top. My title was Favorite Summer Activity. You're going to have a vertical axis over here, so you need a title for it, so these people understand what these numbers mean. So the title says, number of students who chose this activity. And the numbers are going in 5 increments. It counts by 5, 0, 5, 10, 15. And so you need to be careful when you are reading your graph that you look at what the increments are, because sometimes it counts by 1, sometimes it counts by 2, 5, 10. You can make it into a lot of different things. So always check to see what the increments, how is it increasing? And then here is our horizontal axis. And so our title of the horizontal axis is Summer Activities. And here I've listed the 5 choices. Okay, so that is what our first graph looks like. Now when you are looking at graphs, the important thing is that you know how to analyze that data. Yes, it is important to know how to build a graph, absolutely. But without understanding how to analyze the data, they're really worthless. So it's really important to practice that skill. So let's go ahead. We're going to take a look at our bar graph that I just showed you and ask some questions. So according to this bar graph, what is the least favorite summer activity? So you can see here that the numbers go from 0 on up. So the one that's least would be the shortest. And this poor little activity didn't get any votes. So surfing is the least favorite activity. Which activity received 4 votes? Can you tell me before I say it? I'll go over here up to 1, 2, 3, 4. I'm just going to follow my hand down. Oh, that's too short. Oh, that's too high. Oh, that's perfect. Riding a bike received 4 votes. How many more people chose watching TV than riding a bike? Well, let's take a look. Watching TV. Okay, so this is kind of far away from these numbers. You can try to eyeball it, but what would be a really good idea is to grab some kind of straight edge, maybe a piece of paper, a ruler, or in this case I can draw a line, a straight edge, and then I can clearly see, okay, that is 5, 6, 7, 8. 8 people chose watching TV. And the question was, how many more people chose watching TV than riding a bike? Well, riding a bike was down here, and that was 4. So how many more people chose watching TV? Well, then that means you're going to be subtracting, because this is 4 and this is 8. So we want to know how many more. So we're looking at this part right here. What's the difference? So that's when you know you're going to be subtracting. So there are 4 extra people chose watching TV than riding a bike. Okay, very good. Well, for my next question, I did the same thing. I took a poll. I asked the Klessman kids, what is your favorite snack? And here is what you guys said. I put the data into a chart. Here's the favorite snacks. These are the choices that I gave them: ice cream, chips, candy, popcorn, or carrots. And these are the number of students who chose this snack. I just wrote it down. I counted them as they voted. And then I put it into a bar graph. Whoa, this one looks different, doesn't it? See, sometimes bar graphs can go horizontally. You can flip it. Sometimes the bars go vertical and sometimes they go horizontal. And that's okay. Either way is perfect. So first you need a title of our graph, favorite snacks. So that way when someone's looking at this, they can say, what is this graph all about? They're going to look for this title. And then they're going to come over here and say, why are all these foods listed? Well, you need a title. These are the types of snacks. And then down here, what do these numbers mean? Well, these are the number of students who picked this snack as their favorite. Okay, so you can see ice cream had a lot of votes, got all the way to 16. And here's the other choices. So let's go ahead and ask ourselves some questions. What is the favorite snack? I think that one is really obvious. Ice cream. How many more students picked ice cream than chips? Okay, so we know that 16 people chose ice cream. How many more students picked ice cream than chips? Chips is right here. That falls in line. Let me draw a little straight edge so I can be sure. That's right in between these two. This is a 6 and an 8, so this is going to be 7. So we want to know how many more people chose ice cream. So we're looking at this part right here. So we're going to subtract those. 16 minus 7. So 9 more people picked ice cream than chips. Okay, and then which 2 snacks received 6 votes each? Okay, so let's count 6 votes, and let's look up, this is more, this is more. Here's 6, and here's 6. So popcorn and carrots both received 6 votes. Okay, so now for my next graph, I just basically made some observations and kind of a little bit of measurement and observation. So we are looking at test scores for 2 students, Fred and Jill. We're going to look at both of their scores. And these were in the month of January, February, March, and April. And you can see their scores, and you can understand this data. But if you want to see a pattern over time, a line graph is the way to go. So here's my line graph, and here's my title. It's all about math test scores. And here is the vertical axis with my title, points scored on each test. Goes from 0 to 20 to 40. These are in increments of 20. That's important to note. And then alongside here are the months of the tests. So since we're comparing two different people, we're going to use two different colors. This is a good thing to note because when you're making graphs, you can use color to your advantage because the whole point of making graphs is to make your data very obvious just by looking. So if they were the same color, it would be really confusing. But since we made Fred's math scores in blue, what you do is you plot the dot for his scores, and then you connect it with that blue line so you can see over time if he's getting better or worse. And Jill's math scores was red, so you can see hers. We plotted her scores, and then you connect it with that red line so you can follow her score. Okay, so let's go ahead and take a look at some of our questions. In which month did Fred and Jill earn the same score? Well, these two are different scores. This looks like 80 and this looks like about 75. These are different, very different. But here we go, these are the same. So in April, they both scored right here, which was 100. They both got 100 points for that test. Okay, in which month did Fred score lower than Jill on a test? Okay, now Fred is the blue one. Can you figure that out? Which month did Fred score lower? Here the blue is on top. Blue is on top. Uh-oh. Whoa, in March, Fred was struggling. Blue is on the bottom. So in March, Fred scored lower than Jill. In which month did Jill score a 70 on the test? Okay, so Jill is the red. And here is, let's find where 70. This is 60 and this is 80. So someplace in the middle would be 70. That's too high. That is right in the right spot. So this is when Jill scored a 70. And that was in February. All right. So for my next graph, what I did was I took measurements. I measured how fast my son could run one time around the track, which is 400 meters. So on Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, he ran once around the track, and we kept track of how fast he ran in seconds. So these are his scores. And then we wanted to see over time, was he getting better? Was he getting worse? So let's take a look. Okay, so here is our title, Aaron's 400-meter race times. And then over here on the vertical axis, this title is seconds. So you see all these numbers and you're wondering, what do those numbers stand for? The increments are by 10, 10, 20, 30, 40. That's important to note. And then down along the bottom is the horizontal axis. Those are the race dates, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, so what we did was we plotted on here. Monday, he scored a 65. So he ran that in 1 minute and 5 seconds, basically. On Tuesday, he was a little bit slower. He ran it in 70 seconds. So then you can just see, we just plotted it and connected the lines to see if there's a pattern. Now on this line graph I want to show you, if the dot was higher, that was better, wasn't it? Because you want a higher score for a math test. But on this one, he wants to go faster, so a lower number is actually the best, because then that means he's faster. So let's take a look at some questions. On which day did Aaron run the 400 meter the fastest? So if you're looking at this and you weren't really thinking it clearly, you might think the highest dot, oh, he's the fastest right here. But that can't be right, because that means it was like 85 seconds. But down here, the lowest dot is 60 seconds. Okay, so here is the fastest, and that was on Thursday. Here's a fun question. Can you predict which day Aaron tripped while running? Well, if you are trying to run around the track and you trip and fall down, it takes a little bit of time to get back up, dust yourself off, get the courage to keep going. So it's going to take you longer, isn't it? So this dot right here represented the day when he fell down, and it took him a good extra 15 to 20 seconds to get back up and keep going, limping a little bit, and that was on Friday. Okay, last question. In how many seconds did Aaron run the 400 meter on Thursday? Okay, let's see. Thursday was here. Oh, that was his fastest day. You just follow it over. It was 60 seconds. Okay, so you can see how we are starting to really analyze these graphs and ask really good questions about the data. We're not just making it and then walking away. We want to really try to figure out patterns and see if he's getting better. So you can see here, he has scored 65 on 3 different days. So some days he's a little bit slower, a little bit faster. Obviously this one didn't really count since he fell, but I would say 65 is a good average speed for him. And so if his coach asked me, how fast can he run a 400? I would say probably about 65 seconds.
Okay, now it's time to show me what you know. This question says an art club has 2 4th grade girls, 4 3rd grade boys, 10 3rd grade girls, and 8 4th grade boys. Which table correctly shows this information? So you can see the categories here and the numbers. So this would be 3rd grade boys, 4th grade boys, 3rd grade girls, 4th grade girls. So you have to find the table that represents the correct information that's listed in the story. This graph shows the morning temperature in a city for each of 4 days. So here's morning temperature. Here's the temperature along the vertical axis, and along the horizontal axis are the days of the week. The question says the morning temperature on Thursday was 52 degrees Fahrenheit. Based on the data in this graph, which day had a temperature closest to Thursday's temperature? This question says the price of a carton of school milk during 5 years is shown in the table. Here's the title, Milk Prices. Here's the year. And here's the price of a carton of milk, each of those years. Which graph shows the data above correctly? You can see the title says Milk Prices. The vertical axis is the cost of the milk in cents, and the horizontal axis has the years. Which of these two charts shows this data correctly? A or B? All right, we have come to the end of math video number 18. Don't forget, don't close the video until you click on the smiley face and let me know what you think of graphing. You'll have one Study Island lesson to do by Friday. If you want more practice, IXL is always a great place to go. I love this poster. If running is difficult, run more. And this lesson applies to anything. If fractions are difficult, do more fractions. If multiplication is difficult, do more multiplication. So if you found graphing difficult, guess what I want you to do? Do more graphing problems. All right, friends, I will see you later. Have a great week.